Hey everybody, this is Doug with Artfully Rogue, and in this video we're going to be making a couple of gabions. Now if you don't know what a gabion is, it is an Italian word that means big cage. You put rocks in or put dirt in. In my case, we're going to be putting rocks in there. Now I'm making two. They're going to go on either side of the driveway, but I'm going to do something really cool that you don't see with most gabions.
To begin, I need to build the interior structure of the gabion. Here I'm using 2-inch DOM by 0.095 pipe. I decided to use DOM because it doesn't have a seam inside the pipe, and that's ideal because of how I want to use the gabion. For those of you who don't know, DOM stands for drawn over mandrel. It's a cold process where a steel tube is drawn through a die and over a mandrel. And a mandrel is basically a solid rod. This process improves dimensional accuracy, surface finish, roundness, and straightness of the pipe, and its mechanical properties like tensile strength. Although it starts as a welded tube, the DOM process smooths the inside seam so much that it often resembles a seamless tube. In this next step of fabrication, I'm using an 1 3/4 DOM by 0.095 pipe. This slides perfectly inside the 2-inch pipe. To ensure a nice clean fit, I'm cleaning up the outside edges of the pipe so that there are no burrs. In order to clean the inside of the pipe, I'm using a deburring tool. It works great. I'm cleaning up the sharp edges, and as you can see, it's a nice smooth fit. I'll show you later in the video why this is important. With the internal pipe welded together and the test fit of the two pipes, I can now weld on the first external pipe. Now, if you're just wanting a gabion, none of this is really necessary, but I have a very special reason why I'm building an internal framework for this particular gabion. I'm actually making two of these for the front of my property. Now, I could have taken the time to cope the pipe properly. However, because this is on my property and it's just my project, I chose not to waste the time. I'm just going to fill the gap. But if you're curious, coping a pipe is the process of cutting the end of the pipe so it fits snug against another pipe. You typically see this on roll cages and handrails. And in order to fill the gap, I'm just going to go back and forth from one side to the other so I don't heat any part of the pipe more than I really need to. Short welds on each side closes the gap. I'll go ahead and speed up this process just to get through it. Like I mentioned in my last video, this is just one of many projects that I have going on, not just in the shop, but also on my property. I never seem to have any shortage of projects. What projects are you working on? Leave those down in the comments below. Because I want to avoid rain getting inside the pipe, I'm going to put these hemisphere caps on both sides of the external pipes. The center pipe will have an LED light which covers the pipe opening. Once the caps are welded on both sides, I want to add a base plate. And because this is my project on my property, I just took a scrap piece of steel and I'm going to make that the base to keep the internal structure upright while I'm working on it. At the end of the project, you're not even going to see the majority of the framework because it's going to be covered in rocks and concrete. Once I tack on the base plate to the internal framework, I'm going to take some pieces of scrap steel that I've had from leftover water features, and I'm going to use those as gussets. This will help give it a little bit more stability. And this is the internal framework for the gabion complete. Next, I just need to drill some holes to secure the external pipes to the internal framework. You'll see why this is important later on in the video. Now, I'm only drilling one hole in each of the horizontal receiver pipes. And in this case, I'm using a slightly larger than 1/4 inch drill bit. Then I'm just going to drop in a 1/4 inch bolt once the project is ready. The next section is important if you just want to build the gabion itself. Now, the size gabion that I'm making is 24 wide, 24 deep, and 48 tall. I'm using a 2x2 mild steel angle for the top and the bottom frames, and between those frames will be the mesh. I'm going to cut 45s on each one of these angle pieces, and then I'll weld all those together. If you have a workshop and you're using a friction saw to cut steel, you should really consider getting a cold saw. Now, this video isn't sponsored, but I'm definitely fond of Evolution tools. I've had several models of their cold cut saws, and I've been very happy with every one of them. As opposed to all the fine black metal powder from the friction saw, with a cold saw you get small metal chips. One, you don't breathe them in, and two, they're very easy to clean up. Your lungs will thank you. Now this is my hydraulic punch. I call it Eddie because it's a 25-ton Edwards ironworker. It's been out of commission for a while. Because the motor and the hydraulic pump stopped working, and I didn't feel like dropping a couple $1,000s on new parts and a service tech to come out and fix it. But finally I bit the bullet and he's back up and running. Now, before I build the framework for the bottom of the Gabion, I want to punch a few holes in each of the 4 pieces for the bottom frame. This is going to allow me to secure the frame to the concrete slab that will support the Gabion. If you already have a concrete slab, you would need to drill into the concrete slab and use concrete anchors to secure the Gabion to the concrete. However, in my case, because I'm pouring a fresh slab, this is a great method to secure the bottom framework without having to drill. By placing bolts in the framework, I simply drop the frame with the bolts into the concrete while it's still wet and let the concrete set around the bolts. When building the frames, I like to use these metal frame clamps. I've had these for quite a while and they've come in pretty handy. These ones are getting pretty old. It might be time for me to get some new ones. But this allows me to get a rough squared frame, and once I clamp all the pieces in place, I give each corner a quick tack weld just below the top corner to hold everything in place. Then I'm going to remove the clamps and then use my tape measure to make sure that everything is square. Once I know everything is square, I'll clamp the frame down so that nothing moves, and then I'll continue to weld the rest of the frame. I find this important when you're welding to clamp as much as you can, because if not, the steel will bend and warp and end up not being straight or squared. Stainless is terrible for that. Once I finish welding, I add all the bolts in the bottom frames and the holes that I punched earlier. And here, I think I'm just using 5" by 1/4" bolts. The bolt size doesn't really matter, as long as you have some level of depth into the concrete. If you don't have bolts, you can actually get the typical J bolts that you can buy at your big box stores. They're specifically designed to put into concrete. Once I have the frames built, I start working on the mesh. This is a 3/16 wire 2x2 square mesh that I'm using. I want to measure so that the mesh fits just inside the angle framework that I've just finished welding. Once I have that measurement, I'm going to use the flat bar as a guide, then I'm going to score a line. You only want to go about halfway through the 3/16 rod, because I'm going to bend it over my table to make 90 degrees. I found it easier to score the first line and then to cut through the second. So basically, I'm going to make 2 90-degree sections of the mesh, and I'll set those pieces up on my table and weld all that together. You also want to make sure that you weld the corners that you scored. You're going to have a lot of weight inside the mesh cage, so it needs to be very strong. And for mine, I'm using 2 to 3 inch river rock. Once the mesh is welded, I want to test fit into the frame, and in this case, it fits pretty well. You kind of have to give it a little nudge with a hammer though. Once the main mesh cage is complete, I cut a small piece to fill the opening in the top frame, and then do a quick test fit for all of it.
So while I'm over here working on this Gabion, my son's over here working on heavy swords. And yeah, dudes or ladies, if you want something to work out with, that's pretty cool. Hold that out there for 30 minutes, see how long that lasts. Dang. About 7 pounds. Get 2 of those suckers going. Pretty cool. I'll leave a link somewhere up here down in the description. Check them out.
Now at the front of my property, the day before I poured about 2 to 3 inches of concrete in the form so that it could set. Now I can set the welded framework in place. Next, I just need to mix up some concrete, pour that in place, and then let that set. Once I get to the top of the form with the concrete, and while the concrete is still juicy and wet, I can set the lower frame into place. I'm going to take these 2 angle iron pieces of steel and lay that across the top of the form. And then I can clamp the frame to those pieces of angle, and that will keep it right above the concrete line. And then I can fill the rest of the form with concrete, ensuring that the concrete gets in and under the Gabion frame and around those bolts. After 24 hours of curing, everything is set in place, and I can remove those 2 pieces of angle, and the Gabion frame is now in position exactly where I need it. Now, this is the entire reason why I made this internal framework the way I did. I can easily slide the mesh cage over the framework and onto the bottom frame. With the mesh cage in place, I can now cut the openings in the cage to gain access to the internal framework. And once I have access, I can insert the external pipes into the internal framework. Then I'll be able to use the bolts to lock that in place. On the top, I can just drop it in, 1 bolt on each side. But on the bottom, I'll use a magnet and lower the bolt into place. The load on this is going to be horizontal, so I don't need to secure these bolts other than let gravity do its thing. Next, I just need to fill the cage with 3 inch river rock. I drove down to my local landscape company to have them drop about 2,000 pounds of rock into the back of my truck, which cost about $65. And I think I used maybe 3/4 of that per cage. And there you go, the finished gabion. Now, this is the other side of the driveway, which I already completed. As Murphy's Law would have it, my truck broke down the day before I left for Spain, so I was unable to go get more rock to finish the side I was working on. But here you go. You can see how I utilize the internal framework with those external pipes. One side will take care of the anchor points for the fence line, while the other side, closer to the driveway, will actually be the supports for the driveway gate. And then you can see that I added an LED light on top of the gabion, which covers the center pipe opening. But there you go. Thanks so much for taking the time to watch this video. And if you have any questions or comments, drop those below. And if you haven't already subscribed, please do so. It truly helps the lovely little algorithm that we deal with. And I'll see you in the next video.